In this video, we're going to work a problem where we find the components of a force along random directions. We're going to do this graphically. In most cases, you'll have a Cartesian coordinate system, so in either 2D or 3D, you can represent your forces and directions with components and use the dot product to get components of the forces along any direction. But it's still valuable to practice problems with vectors graphically. You learn a lot of the geometry involved in working with vectors. Also, even with a Cartesian coordinate system, if you're resolving graphically along random axes that aren't perpendicular, then you still may need to use the law of sines or law of cosines to get information. So it's good to practice working with the law of sines and law of cosines and analyzing triangles that aren't right triangles. Okay. So let's get started. This first problem, it says resolve F1 and F2 into components along the U and V axes and determine the magnitudes of these components. Okay, so let's start with F1. So we start the tail of F1 and we walk along the axes. So we're walking along the U axes, and then eventually we'll stop and then walk along the V axis to get to the head here. So the V axis is straight up and down. So at this distance is F1U, right? The component of F1 along the U axis, that's this distance. And then this distance is F1V. So now we just need to use the law of sines and cosines to find these distances, or the lengths of this side of the triangle, these sides of the triangle. Because, right, it's not a nice right triangle. These are just random directions. It's not, this one's straight up and down, but if U was to the left and right, well, then we could use the Pythagorean theorem or sines, cosines, and tangents, but we can't do that here. Okay, so here's the law of sines and cosines. This is 250. This is 30 degrees. So we still need another angle or another side length. So what we can do is use geometry, draw a line parallel to the U axis here, and then there's a line parallel to the V axis, and see what we can find. Okay, so we've got opposite interior angles here. So this is 30 degrees. Okay, if you look here, this is 105 degrees, right? And then, so these angles are equivalent. So this is 105. Okay, so let me take this off, and we've got 105. So this angle then is 180 minus 30 minus, so 45. Okay, so now we can say, using the law of sines, sine of 30 divided by F1V is equal to sine of 105 divided by 250. So F1V is equal to 250 sine of 30 over sine of 105. So F1V is equal to 129.4. newtons. Okay, for F1U, we use the law of sines again. We say sine of 45 over F1U is equal to okay, F1u is equal to 250 sine of 45 over sine of 105. $183. Okay, now for F2, we walk along the U. We walk from the tail of F2 along the U direction, and then we're going to be walking straight up and down. Okay, so this was F1V, and this was F1U. So this is going to be F2U and F2V. And then to determine our angles, this is 105 degrees. So this is 105 degrees, right? Both of these are 105 degrees. So now if we do 180 minus 105, you get 75. So this is 75 degrees. Now to determine this angle, we say 180 minus 30 minus 75 is 75. Okay, let's use the law of sines, and well, okay, this is 150. So sine of 75 divided by 150 is equal to, let's do F2V. So sine of 30 divided by F2V. So F2V is equal to 150 sine of 30 over sine of 75. So F2V, so 150 times sine of 30 divided by 77.6. Okay. Now the component along the U direction. So we'll say, okay, sine 75 divided by 150 is equal to sine of 75 divided by F2U. We get F2U is equal to 150 sine of 75 over sine 75. F2U (150 newtons).